Yeah, all good. Yesterday wasn't too bad. Probably not looking forward for the homework probably. Okay. All right. So there's no questions. One thing I just want to quickly go over, since I went at the end of the lesson yesterday and people left out before I said anything, so they might not go back. So just to summarize, so this is a fun extra credit opportunity for you guys. This is due the last day of class. So let me show you. Oh, you guys know what the last day of class is, right? You know, the final day. I think it's the 30th or 29th, the 29th. So you have about a week and a half to see if you guys want to try it. So it's a music video. And what it is if you can find me in this music video, I'll give you extra credit. Okay. All you have to do is, screenshot it and just, send it to me. And then I'll say yes or no. And you can guess how many times you ever want. So if you want to guess 100 times, go right ahead. I've had people email me like almost on a daily, try to see, but if you can find me anywhere in this music video, I'll give you the extra credit itself. And it's Hey featured Afrojack. So for the few people that left before I was able to do that yesterday, that way I have it here. Okay. So fun little extra opportunity if you guys want to see. It's pretty cool, dude. I like his songs as well. Okay. All right, so that's that portion. So today we're pretty much finishing up the entire semester. Obviously we still have one more section, but 2.2 is it's not too bad. We'll get done with that pretty quickly. But today is the big bulk, just like yesterday. It's a lot of information, and we're slowly but surely going to break it down when it comes to it. Okay. So I put these two sections together because essentially one is attached to the other. So I just put them both together when it comes to it. So that's the reason why if you guys look at your workbook, I put just both properties and inverses together because they're basically the same thing anyways when it comes to it. Okay. All right. So today we're going to learn the last way to solve for a system of equations. Okay. So we've learned so far graphing, substitution, elimination, right? The old-fashioned ones. And we'll learn two more new ones, and this is going to be the last one. And believe it or not, it's going to be the last section talked about inverses themselves. Okay. And there's like everything else. You can go one way, you can go another way. So the same thing applies for matrices of inverses and stuff like that. But the inverse of a matrix is actually much easier-ish to do when it comes to it. Okay. All right, but before we go there, let's talk about some properties. Okay. All right. So just like everything else, what we can do is we can always add, subtract numbers. We can add, subtract matrices. Okay. And how we add, subtract matrices is we do, I call it element. So element by element. So if it's like this portion here with that portion, you just add each individual case together. So you would add these together, those together, those two, and then those two. It gives you a whole new matrix when it comes to it. Okay. Pretty straightforward, right? You just add each individual element to itself when it comes to it. Okay. However, this is the key thing. So hint maybe on a quiz or next week as well. In order for two matrices to be added together, they must have the same dimension. So they both have to be, like a 2 by 5, 3 by 5, right? But they both have to be at the same dimension. So if one is a 2 by 3 and the other one is a 2 by 4, you cannot add them or subtract them together. They have to be the same dimensions, right? When it comes to it. So fair warning there. Okay. So when add subtracting, they have to have the same dimensions. Okay. Scalar multiplication, we've already talked about this before. All this is saying is, given a matrix, you can multiply a number in the matrix itself, where we already done that before as well, right? When we did row reduction, so you could just multiply by anything you want. What this is saying now is you could multiply the entire matrix by one single number, not just a row individually. So, we've already done it. Just go talk about it when it comes to it. But the big one we're going to talk about today is the multiplication, because believe it or not, there's no such thing as division when it comes to matrices. So there's only adding, subtracting, and multiplication. There is no such thing as division. And you'll figure out why there's no such thing as division. We'll talk about that in a little bit as well. Okay. So multiplication is the main concept we want to do, in this portion here. So here's a key thing when it comes to multiplication. So unlike regular numbers, right? So I could say 5 times 2 is the same as 2 times 5, right? It doesn't matter how you write it, it's still going to give you 10. That's not the same with the matrices. So that's the one thing you got to be very careful of. Okay. So when it comes to matrices, the way you multiply is the way you read it, from left to right. Meaning, A times B is not the same as B times A. You will actually get two completely different answers when it comes to it. And we'll do a question just like that so you can see how it's going to go about when it comes to it. Okay, but that's the key thing. The order in which they actually want you to do it does really matter when it comes to it. Okay. All right, so any questions so far on a little theory behind the properties of matrices? No, nothing too bad. Okay, so in that case, why don't we do some examples so you can see, you know, how these examples are going to be played out as well. Okay. Oh, actually, there's one more property, number 4. Actually, let me go back to number 4. I'll do number 4 afterwards to do some examples. So let's just do little examples of the first one. Okay, just adding, subtracting matrices so you can get accustomed to that. Okay. So let's suppose we have this matrix here. And I want to add it to this one here. So let's suppose like this is matrix A, matrix B. Okay. So first off, one of the things I got to figure out is, can I actually do it? In other words, you know, can I literally actually add these together, right? That could be a problem. So first we got to find the dimensions and see, are they the same? So remember, rows come first. So this is a 2 by 1, 2, 3. So this is a 2 by 3 matrix. And this is also a 1, 2 by 1, 2, 3. All right, so good. They're the same. So therefore we can actually add them. Again, fair warn on your homework quiz and maybe next week for your final, you may be an option where you say you can't. So it's an easy just fix, right, when it comes to it. So just be careful about that. Okay. All right, so now we can do it. We're going to add across. So do element by element. So it's going to be 8 minus 3 gives you 5. 8 plus 4 gives you 12. 3 minus 10 gives you negative 7. Negative 10 plus 0, negative 10. 0 plus 5 is 5. And then finally 5 plus 2 is 7. And that's it. So that's all you have to do. And same thing when you subtract, right? So you would subtract, you do 8 minus negative 3. You know, that would be adding. So that would be, in this case, 11, right? So add, subtract, and matrices are pretty straightforward. Again, the only key thing is you got to remember is they both have to have the same dimensions when it comes to it. Okay. Questions on first concept, adding, subtracting matrices. Pretty straightforward, much easier than the stuff we're doing so far with row reduction. Yeah, I'm pretty sure, huh? When it comes to it. All right, so second property is scalar multiplication, and this is very simple. All this is pretty much saying is if I have a number out here, so let's suppose I have this matrix here. Okay. And I have a number out here, and I'm multiplying it by, let's say, 2. Okay. So again, all this is saying now is I'm multiplying every element in there by 2. That's it. That's all it is it's talking about. Okay. So just 2 times everything. You're just going to distribute this 4 times. So 2 times 3 is 6. 2 times 4 is 8. Negative 16 and 10. That's it. That's what scalar multiplication means. So you just multiply number on the outside and you just distribute inside the matrix. That is all. Okay. So, now, the one we're going to care about the most and the most difficult one is going to be number 4. Okay, when it comes to multiplication. So just like when it came to adding and subtracting, where they have to have very, you know, distinguished elements, you know, they both have the same dimensions. Also, scalar multiplication has to be a little different as well. So if A, B, and C are matrices, and then we already talked about this, right? The order does matter in this case. However, this is the key thing. In order to multiply matrices, one must be an R times N matrix, and the other must be an M times N matrix. Okay? So the resulting matrix is going to be an R times N. Okay? Now, that may be a little confusing, So if it's easier, the way I was able to remember this kind of matrix multiplication is this number here. So the column of your first one must be the same as the row of your second one. So notice the result is just the outer one, right? The R and the N. That's what makes it up there. Okay. All right. So before we actually multiply matrices, right, let's just do a little practice. Okay. So let's suppose we have matrix A, which has dimensions 3 by 4. Matrix B has dimensions, let's say, 4 by 6. And matrix C has dimensions, what do we say, 5 by 3. Okay. All right. So the whole goal is to figure out, can we multiply some stuff? So first thing is this possible? So if I say A times B, what would the result matrix end up being if we would multiply it, right? So kind of like the situation here. Okay. So here's A and here's B. So again, going across as we read, A comes first. So according to our rule, there we go, one there. It's going to be the column of this must be the same as the row of that, and it is, right? So that's good. So the resulting matrix, if I just cross this out, would be a 3 by 6. So again, if we would actually multiply, the result matrix would be a 3 by 6. So 3 rows by 6 columns. Questions on that? Yep, everybody comfortable? Okay, let's do some more. All right, so let's suppose now we do A times C. Okay. Again, we want to figure out what would the dimensions be if we would multiply. So this is A, this is C. So same thing, right? So A is over here, comes first. So that's 4. So 4 must be the same as the rows on this one, but it's not, right? So 4 does not equal 5. So automatically you would say cannot do, or just not possible. And that's your answer. It is not possible. So maybe you have a question on this on the homework. You just, oh, easy, not possible. Next, right? And keep going. So it's just like an easy question. Okay. However, what if I flipped it around? I did C times A. All right, now let's look at these ones. So here's C, right? It comes first. So therefore, the column of this must be the same as the first row of that, and it actually is, right? 3 and 3. So the resulting matrix is going to be a 5 by 4. So that one does actually work, and that's the reason why order does actually matter. So one was impossible, the other one is possible to actually create it. Okay. So any questions? If I just give you a general one and just ask, what are the scenarios you can have, right? So we're not multiplying yet, right? All I'm asking you is it possible to do it? And if it is, what's the resulting matrix you would have based on our rule right here? Is everybody comfortable? Yeah, okay. All right. Now that we have that out of the way, now comes the hard part. How do we actually multiply? Okay. So multiplying matrices. Okay. So I'm going to do a generic one. So let matrix A be the values A1, A2, A3, and A4. And matrix B be B1, B2, B3, and B4. Okay. And we're going to be doing A times B. So it would work, right? A 2 by 2 and a 2 by 2 will give us a result of a, let's see. So this is a 2 by 2, and this is a 2 by 2. So the result is going to be, so I usually make this easier, also a 2 by 2, right? Now, when it comes to matrix multiplication, it's very, very interesting, believe it or not, how computer software does actually this. It's pretty cool. Okay. It's a little confusing, so I'm just going to go through the steps, and then we do lots of examples, so don't worry. Okay. So we know it's going to be a 2 by 2 matrix, so we're going to have 4 numbers. The question is, how do we get those 4 numbers is the most interesting part. Okay. So just follow along, and then, you can ask questions later, but just let me finish this theory, and we can just do the questions afterwards. Okay. So how this is going to go about is you're going to multiply the first row times its first column here. Confusing, I know, but it's going to be row times column. And how that's going to go is going to be A1 times B1. So A1 times B1 plus A2 times B3. So it's literally this whole row times this first column. That's going to be the first one there. So once you multiply and take the sum, that's only 1 out of the 4 numbers we need. So we're going to do this 3 more times. Okay. So the second entry here is going to be, again, this first row times this second column. Or in other words, A1 times B2 plus A2 times B4. And believe it or not, we're going to mimic what we just did for the bottom ones. So instead of using this one now, we're going to use this one here. So for the next 2 entries, it's going to be this row times, again, each respective column there. So it's going to be A3 times B1 plus A4 times B3. And then the last one, it's going to be A3 times B2 plus A4 times B4. And that's how we multiply matrices together. A lot more complicated than just adding, subtracting. So let's try an example out. So let's suppose we have 2 matrices, A and B, being those the respective matrices themselves. Okay. And the first thing we're going to do is going to do A times B. Okay. All right, so we need A first. So we make this big matrix. So A first, then B. So we're going to do, so literally you're just going to follow this template and make ourselves out, because it's going to be that same template here, right? So it's going to be the first letter here, so 3 times this column. So notice A1, this is B1, times B1, so it's going to be 5, plus A2, which is 0, times B3, which is 1. And now we move on, okay? A1, which is 3, times B2, which is 4, plus A2, times B4. Is everybody good with the first row at least? And now we're going to mimic what we just did, but now we're going to use these ones now, right? So we go down here, A3 times B1 plus A4 times B3, which is also 1. And then the last one, so 8 times 4 plus 1 times 0. And now all we're going to do is just simplify. Ready? Multiply and then add them together. So 3 times 5 is 15 plus 0. That's just 15. Over here, 3 times 4 is 12. Then 12 plus 0 is still 12. Okay. 8 times 5 is 40 plus 1, so that's 41. And then finally, 8 times 4 is 32. Yeah, 32 plus 0, so it's just going to be 32. So that is the answer. We multiply A times B together. Any questions? No? You guys are starstruck?
Just to throw it out there, B said had, I don't know, 3 columns. We wouldn't need, the answer would just be not possible.
Correct.
Okay.
So we would be in situation B right here.
Okay.
So it means you didn't even have to do all this. You just say not possible because it literally isn't possible. Yeah.
Only because they're both 2 by 2 matrices.
Well, yeah, because this work. I could make this a 3 and it still would work, right? The result would be a 2 by 3. But if this was a 3, it wouldn't work.
Oh, okay.
Yeah. And we'll do those. We'll do different lines so you can see how that would work out. Okay, let's try another one. So this time, why don't we just flip it? Let's do B times A now. Just the opposite. So opposite order of what we just did. All right. So now it's going to be flipped, right? So we're doing these first and that. So it's going to be, so if it's easier, I'll do this. Put it here. It's be 5, 4, 1, 0 times this one. Okay. So that way you can mimic exactly what we did here. So we're doing this to that. So we're doing this to that when it comes to it. Okay. All right. So the first one's going to be 5 times 3 plus 4 times 8. So you can already tell it's going to be different, huh? When it comes to it. All right. So next one, same numbers, but now we use the same next column. So it'll be 5 times 0 plus 4 times 1. Again, I'm just following the same template we did there. The only difference is now this, right? This is A1 and so forth. So same process. So if you're wondering, we're right here now. So it's going to be these two numbers. So 1 times 3 plus 0 times 8. And then lastly, 1 times 0 plus 0 times 1. Right, so as long as you just follow it, you'll be perfectly fine. It really doesn't matter what A and B is, as long as you just follow the matrices. You should be good. Right, and then we just simplify this one. All right, so we need a calculator for these ones. So 5 times 3 is 15. 4 times 8 is 32. So 15 plus 32 gives me 47. 5 times 0 is 0. So 4 times 1 is just 4. So that's just 4. 3 times 1 is 3 plus 0. So it's just going to be 3. And the last one, it's all 0. Right? There you go. So notice it's crazy different, right? They don't even have one number in common. So the order of which you do multiplication does matter dramatically. Okay. So any questions so far on multiplication with matrices? And again, we'll do some more examples, so don't worry. Nothing yet? Okay. So let's keep going then. Let's do some more examples. So let's suppose this matrix A was this. And matrix B was this. So before we start multiplying, I just want to write down their dimensions. That way, I get that out of the way so I can see if I can do any of these problems we're about to do, okay? So first dimension, this is a 1, 2, 3 rows by 1, 2 columns, right? And this one's easy, right? This is just a 2 by 2. Those are the ones we have all the time. Okay. All right, first one. Let's do B times A. So that's going to be B first, and then this A1 here. So before we do anything, the question is this possible? This is a 2 by 2. This is a 3 by 2. Can we multiply?
I thought we can't, right? Because the 3 would actually have to be a 2.
Yep, these are not the same numbers, so this is not possible. And you're done. If you could, right, you'll be a genius and they'll give you a PhD off the bat, but it's not possible. All right, that's it. So if you have a question just like that, boom, not possible. No work involved, right? Just identifying if you can. Well, let's see if the other way is possible. A times B. So this way is this times that. So I'll just rewrite this. This is 2, 5, 4, 5. This is a 3 by 2, and this is a 2 by 2. So what about this way? Is this possible?
Yes.
Yep. So again, the easiest way, if I just circle these and make sure they're the same number. So yeah, it is. Which means we know the resulting matrix is going to be a 3 by 2 matrix. So I'm going to have 3 rows by 2. So essentially, kind of like this. That's what's going to happen when it comes to it. So a little different than a 2 by 2, right? So how are we going to get these numbers out when it comes to it? Okay, so What if it's not a 2 by 2? You know, it's a little bit more work, but it's still doable. So I'm going to show you guys how that's going to go about when it's not just a basic 2 by 2 matrix all the time, because, you know, unfortunately, life is not always perfect. And you'll believe it or not, you'll see in a little bit like 2 by 2 matrices are the perfect ideal stuff to deal with. Okay. So how this is going to go about is we were going to have 3 columns, or sorry, 3 rows, 1, 2, 3 rows, and 2 columns. Okay, so that means we're going to have 2 numbers, 2 numbers, 2 numbers, total of 6 numbers in between here. But how are we going to do that? Well, we're going to follow the same template we did last one, right? It's going to be this row times that column, and then this row times that column. That's going to be the first 2, and we're going to do the middle, and then finally the last ones. So if you think of it, it's the same as a 2 by 2 with just 2 extra steps. That's all we're really doing when it comes to it. Okay. So first one, like you can think of this as like A1. So A1 times B1 plus, what is it, A3, so that's 5, times B4, that's 2. That's the first one. Just like we did a last example, right, when it comes to it. Next one is going to be this one, so 5 times 2, or yeah, times 2, plus, no, what am I doing? 2 times 2. I'm confusing myself. 2 times 2, yeah, that's the one. Plus, I should put a little higher, 5 times -1. This is way out here more. Give myself more space. Okay. And now we're going to rinse and repeat for the middle term. So now the inner one. So it's going to be 4 times 2 plus -2 times 5. And that's it. And now for the next term, go back here. So 4 times now these ones times 2 plus -2 times -1. And now finally, the bottom ones. So 0 times 2 plus 5 times 5. And then finally, 0 times 2 plus 5 times -1. So notice this is the same pattern, right? Once you get 1, you do the same thing for the middle and then the bottom. And again, at this point, all we're going to do is just slowly add and multiply. So 2 times 2 is 4, 5 times 2 is 10. So 10 plus 4 is going to be 14. Over here, 2 times 2 is 4, 5 times -1 is -5. So 4 minus 5 is -1. So now we do the middle ones. So 4 times 2 is 8, and this is going to be -10. So 8 minus 10 is -2. Next one. This is still 8. This is +2 now. So 8 plus 2 gives you 10. This is 0. So this could be 25. And then finally, last one. So again, this is 0. And this is going to be -5. And there is your answer there. So that's the result. I'm multiplying it this way. So one way was not good. One way was good. Any questions on this example? Yeah, everybody comfortable? Okay, let's try one more before we move on. And let's suppose we want to find out what C times D is. So again, same thing. Is it possible? So I'll leave it up to you guys. So in the chat, yes or no? Possible or not? So it is possible, right? Definitely possible because they engulf. So the result is going to be a 2 by 2. Now the real question is, how in the world do you get a 2 by 2 matrix with these things, right? And that's the cool thing about matrices, how these actually work out when it comes to computer programming. So we know it's going to be a 2 by 2 matrix, so it's going to be pretty big, right? So we need 4 numbers in our matrix. Now, I claim that this is actually a really, really easy one compared to the one we just did. Okay? But let's find out. Okay? Remember, if we follow our template, it's going to be the first row times its first column. Well, what's 2 times 1? 2. That's it. No adding. Look at that. Get the next one. First row times its next column. 2 times -3, -6. Ah, much easier already, huh? Keep going. Now we go to the second one. -5 times 1, -5. And then lastly, -5 times -3, +15. And believe it or not, that is your answer. So the question now becomes, is this possible? D first times C. Interesting. Let's find out, right? This is D, so this is a 1 by 2, and C is a 2 by 1, so it is possible. You'll get a 1 by 1 matrix. So yes, it's possible. And we'll do it together. So as you can see how this would work out. So D comes first. So it'd be 1, -3 times 2 by -5. So this is a 1 by 1. So literally is just a single number. Right? There's just only one single number. But how do we get that? It's even easier. Right? Again, row times column. So 1 times 2 plus -3 times -5. So again, the result is just adding those numbers up. So 1 times 2 is 2. This is going to be +15. So literal 17 is our answer. And this is why there's a whole other class just on matrices, believe it or not. So there's a lot of stuff. Again, we're just cracking the surface of what you can really do in matrices, and how, you know, computers are actually programmed in the language of computers is pretty interesting. Okay. But again, why do we care about doing this, right? You know, what's the major issue, right? So the whole goal, remember, is to